In the second video, we will see some examples of integrals of exponential functions using integration by substitution. So in this example, we have x to the fourth times e to the x to the fifth dx, and that's what we're integrating. Since we see an x to the fifth and its derivative x to the fourth in the same problem, we're going to let u equal x to the fifth. Then du will equal 5x to the fourth dx. So now if we make the substitution, we'll have the integral of e to the u. And if we look at what's remaining, we'll see that we need to express x to the fourth dx in terms of du. So in this case, x to the fourth dx is just 1/5 du. So now if we make the substitution, and we'll replace x to the fourth dx by 1/5 du. And now this is an integral that we know right away because the integral of e to the u is just e to the u. So we'll have 1/5 e to the u plus our constant of integration. And then our last step is to do the back substitution. So instead of u, we'll replace u with x to the fifth. In the second problem, which also involves exponential functions, we want to start by simplifying the expression that we're integrating. So in this case, 7e to the x plus 10 divided by e to the x is the same as 7 plus 10 over e to the x, or I can write 10e to the minus x dx. So integrating the constant 7 will just give us 7x. Now how do we integrate 10e to the minus x? Well, the 10 will be the factor out front. To integrate e to the minus x, remember that the integral of e to the ax dx, where a is some number, is going to equal e to the ax over a plus a constant of integration. So in this case, a is equal to -1. So the integral of e to the minus x will be e to the minus x over -1 plus our constant of integration. And finally, if we simplify this a little bit, or rewrite it actually, we'll have 7x minus 10 e to the minus x plus c. And if we wanted to check our work, we could take the derivative of our answer, and we should end up with identically what we started with. In this third example, we see something that looks similar to what we had in example 2. However, in this case, we don't just have a simple one single term, e to the x, in the denominator, so we can't distribute. So we have to try something else. So let's try a u substitution, and let's let u equal 7e to the x plus 10. Then du will equal 7e to the x dx. So if we make the substitution, we'll have the u in the denominator, and the remainder will be the e to the x dx. E to the x dx is actually equal to 1/7 du. So now we can make that substitution. So we'll just write 1/7 du instead of e to the x dx. And now we can solve this integral. This will be 1/7 times the integral of 1 over u to u is the natural log of the absolute value of u plus our constant of integration. And finally, doing our back substitution, we'll have 1/7 times the natural log of the absolute value of 7 e to the x plus 10 plus our constant of integration. And here we could, if we wanted, drop the absolute value sign, because 7 e to the x plus 10 will always be positive.